Hello students, in previous session we have seen the books we have to refer for preparing the subject. Already I have told you the name of book Mastering Blockchain by Imran Basir. That book is available on internet, you can download that book. And then also we have discussed about the NPTEL course by uh, Sandeep Chakravarti. This course is from IIT Kharagpur. So I request to all students to watch the sessions of Sandeep Chakravarti that are available on YouTube. So in this session we are focusing on smart contracts, blockchain, block and transaction. In the previous session we have studied what is public ledger, then network view of the blockchain. Also we have studied the Bitcoin and how the transactions are processed in the Bitcoin. So in today's session we will revise the previous session. Also we have to study some new topics like smart contracts, blockchain, generic elements of the blockchain, block in a blockchain and block elements, and we have to also study how the transactions are processed in the blockchain. That also we have to study in this session. So first we will start with the revision of previous session. In previous session we have studied what is public ledger, network view of the blockchain, Bitcoin, and that topics we will revise, and then we will study some new topics. So students, we will keep this slide till we finish the unit 1. So this is to keep the track of the things that are covered in sessions. So in unit 1, the unit 1 syllabus is divided into two parts. First part contains blockchain overview and second part is about the security aspects of the blockchain. So far we have studied the overview of blockchain, we have studied what is public ledger, also we have studied Bitcoin, and in this session we have to study smart contracts, block in a blockchain and transactions. So this slide we will keep till we finish the unit 1. So this is to keep the track of the topics and that we have covered in previous sessions. So we will revise in short what is public ledger. Public ledger is a distributed ledger or public ledger, which simply means that a ledger is spread across the network among all pairs in the network, and each pair holds a copy of the complete ledger. So this ledger is distributed across all the nodes in the network, and each node holds the copy of the ledger, and the transactions are recorded in the ledger. When the transaction is finalized, the transaction is recorded. Ledger is nothing but a blockchain. Whenever we complete a transaction, whenever the transaction is validated by all the nodes, the block which contains the transaction, that block is appended at the end of blockchain. Shared ledger or public ledger is a generic or broad term that is used to describe any application or database that is shared by the public or consortium. Generally all blockchains fall into the category of shared ledger, but every shared ledger is not a blockchain, that we know and we have studied in the previous session also. Although all blockchains are fundamentally distributed ledger, but all distributed ledgers are not necessarily a blockchain. So this we have studied in detail in previous sessions. So we have studied the four definitions of blockchain in previous session. First definition is a blockchain is a decentralized computation and information sharing platform that enables multiple authoritative domains which do not trust each other to cooperate, collaborate and coordinate in a rational decision making process. So the blockchain is a distributed information sharing platform, and this platform enables all the parties that do not trust each other to cooperate, coordinate and collaborate in a rational decision making process to complete a task. Then we have studied second definition, layman's definition. A blockchain is an ever-growing, secure, shared record-keeping system in which each user of the data holds a copy of the record, which can only be updated if all the parties involved in a transaction agree to update. So the main part of this definition is, if you see, this definition has the word each user holds a copy of the record, each user holds a copy of the ledger, and this ledger is updated if all parties agree to update. If all the parties agree on the transaction, then this ledger is updated, block is inserted in the blockchain. Then technical definition, blockchain is a peer-to-peer distributed ledger that is cryptographically secure, append-only, immutable and updatable only via consensus or agreement among the peers. So if you see, there are several keywords in this definition. Blockchain is a peer-to-peer system, then it has distributed ledger. Then next keyword in this definition is blockchain is cryptographically secure. Then next keyword is append only. Then other keyword in this blockchain is this definition is immutable. That means once the transaction is recorded, that transaction cannot be altered, that transaction cannot be changed. Then another important part of this definition is blockchain is updatable only via consensus or agreement among the peers. If the peers or the nodes agree to update the transaction, then only the transaction is updated in the blockchain, and the block that contains the transaction is inserted in the blockchain. Then from business point of view, there is one more definition. A blockchain can be defined as a platform where peers can exchange value or electronic cash using transactions without the need for a centrally trusted arbiter. So the main component of this definition is blockchain can be defined as a platform where the peers can exchange the value or electronic cash, and other main component is it has centrally trusted, there is no need of centrally trusted arbitrator. So there is no need of third party to control the transaction. So this is the main important aspect of this definition. So there are several keywords in the definition: peer-to-peer, distributed ledger, cryptographically secure, append only, and this updatable. Blockchain is updatable via consensus. That means when the parties will agree to update the block, then only that block can be updated. Otherwise the blocks are immutable. That means blocks cannot be tampered. So we know about the peer-to-peer network, distributed ledger. The blockchains are secured by the cryptographic methods. Append only block can be appended at the end of the block. So this we have studied in the previous session also. Then we have studied the network view of the blockchain. This network view is like a ISO OSI model of the network. So in this there are 4 layers. The bottom layer is internet. Then above the bottom layer there is a peer-to-peer network, and third layer is blockchain layer. In this blockchain layer the several things are combined, like transactions, blocks, consensus, state machine and blockchain application. All this make a one layer that is shown in the by the lines, and this blockchain layer consists of 5 components: transaction, blocks, consensus and state machine, and also blockchain applications. And above this layer the fourth layer is user or nodes. So we have studied Bitcoin definition. Bitcoin is a combination of peer-to-peer network. Bitcoin is a combination of peer-to-peer network protocol software that facilitated the creation and uses of the digital currency named Bitcoin. So this Bitcoin is a peer-to-peer network protocol software that facilitates the creation and uses of this digital currency. We can exchange the digital currency, cryptocurrency, by using this Bitcoin network. So this is the decentralization of currency. The decentralization of currency was made possible for the first time with the help of Bitcoin. So this Bitcoin solves the problem of double spending. So we have studied this double spending problem, and in future sessions also we will go into the details of double spending. So we have studied, students, what are the main components of the Bitcoin. The first component is digital keys. Whenever the transaction is initiated, the node will sign the transaction. It will be signed digitally by using the private keys, and public keys are used by the nodes to verify the transaction. And then addresses, there are addresses used to denote the sender and receiver. And then transactions are not encrypted and are publicly visible in the blockchain. The transactions are visible to all the nodes in the Bitcoin network, and every node has to validate the transaction, and for validating the transaction the nodes will get reward. The identity of the owner who will initiate the transaction, that identity is confidential, that identity is hidden in the Bitcoin network. Then blockchain miners are nothing but nodes. Miner is nothing but a computer that will validate the transaction, and miners get reward for validating the transaction. Then the next component of Bitcoin is Bitcoin network and wallets. Wallet is a software used to store private and public key. This wallet is on the node of the user of this Bitcoin network, or we can say mobile, that will contain a software, and it will contain the private keys and public keys and Bitcoin address. It performs various functions such as receiving and sending the Bitcoin. So this part we have studied in the previous session. So how the transactions will happen in the Bitcoin network? This is similar to the blockchain, as the Bitcoin network is a blockchain network. The blockchain provides the infrastructure for a Bitcoin. Transaction starts with the sender signing the transaction with their private key. The sender, the node who wants to initiate the transaction, it will start the transaction by signing that transaction with their private key, and transaction is serialized, or you can say transaction is flooded in the Bitcoin network, so that it can be transmitted over the network, and transaction is flooded, or you can say broadcasted to the network. For this it will use the gossip protocol. Then miners listening for the transaction, miners will pick up the transaction, and transaction is verified for their validity by the miners. Miners will validate the transaction, and if the transaction is validated, then transactions are added to the candidate or proposed block for mining. Then the transaction, the block is created with that transaction, and block is ordered in the blockchain network. So this is how the transactions are processed in the Bitcoin network. This is similar to the any transaction processed in the blockchain network. So this we have studied in the previous session also. So once the transaction is mined, it is validated, verified, the results are broadcasted to all the nodes on the Bitcoin network. So every node will update the copy of the ledger. Every node has the copy of ledger, copy of the blockchain, and that blockchain is updated after the transaction is finalized, after the transaction is committed. So this we have studied in the previous session also. So students, in today's session we are focusing on the smart contracts, blockchain, then block, and how the transactions are processed in the blockchain network. So we will start with the smart contracts. In simple words, we have to understand what is smart contracts. Whenever there is a business, that business will happen on some conditions. Whenever the buyer will buy some goods, then it will spend some money, and there are some conditions about the quality of the item, or there are several, whenever there is a business between two parties, this business will happen on some conditions, and these conditions are nothing but smart contracts in Bitcoin network. But in day-to-day operations, day-to-day business, these conditions are manually written on paper, or it can be stored in the electronic form. But in uh, smart Bitcoin network, first we will see the definition of the smart contract, and then we will talk about the smart contracts in definition. A smart contract is a secure and unstoppable computer program representing an agreement that is automatically executable and enforceable. So you can see, the students, a smart contract is a secure and unstoppable computer program. This smart contract is a computer program representing an agreement, and this computer program will represent the agreement that is automatically executable and enforceable. These smart contracts are automatically executable, and these contracts are enforced. There is a duty of the this program that will enforce the agreement, and if these agreements will meet, then the transaction will happen in the Bitcoin network. So this is the duty of this computer program, this smart contract program. It is a secure program. This program cannot be stopped. This program cannot be stopped. It cannot be terminated. This program is designed in such a way that it cannot be stopped. It is always there, and it will automatically execute the smart contracts, and it will enforce the smart contract. If certain conditions, certain agreements are met, then the transaction will happen in the Bitcoin network, and this is the duty of this smart contract program. So in definition, we have seen this smart contract is a computer program that is written in a language that a computer or target machine can understand. This program is written in such a way that the computer or target machine can understand this program, and also it encompasses agreements between the parties in the form of business logic. So this smart contract will enforce the business logic when the agreement is made, whenever the conditions in the, it will verify the conditions in the agreement, and if that conditions are met, then it will go ahead to finalize the transaction. So fundamental idea about this smart contract is these smart contracts are automatically executed when certain conditions are met. When certain conditions are met, this program is automatically will come into the picture. It will verify the business conditions, and if these business conditions are met, then it will allow to process the transaction. These programs are enforceable. This program will enforce the conditions. They are enforceable, which means that all contractual terms are executed as defined and expected. So this program will execute all the contracts as specified in the business contract, and whatever the conditions that are expected to fulfill, if that conditions are fulfilled, then that transaction is allowed. So this program is there, and if the conditions are adverse, if the conditions are not favorable, in such conditions also this smart contract will execute the conditions. It will see whether the conditions are fulfilled or not, even if the business condition is not favorable. Instead of that hurdle also, it helps to execute and enforce the business agreement, and if that agreement is not fulfilled, then it will not allow the transaction. So this is the duty of this program. This program is unstoppable. It is automatically executed, and it will enforce the business condition, and if the business conditions are fulfilled, then it will allow the transaction. So these programs, smart contract programs, are secure and unstoppable. These programs are secure and this cannot be stopped, which means that These computer programs are required to be designed in such a fashion that they are fault tolerant and executable in a reasonable amount of time. So, these programs are designed in such a way that they are fault tolerant, and this program cannot be stopped, and these programs are executable in a reasonable amount of time. These programs will verify the conditions in reasonable amount of time, and if that conditions are met, then it will allow the transaction. So, this is smart contract program. This is a program that will verify the business conditions. So, more about the smart contracts. Smart contracts usually operate by managing their internal state using a state machine model. So, the dear students, try to understand the concept of state. What is state? Whenever there is some state and some program, suppose, and that program will operate on some data, and if we give some input, and before processing on that data, there is some state of that data, and after giving some input and after processing on that data, that will change the state of that data, and we have another state. We have previous state and now current state. So, such type of states are used to represent the state of the machine. So, this is called state machine model. So, smart contracts usually operate by managing their internal state using a state machine model. This allows development of an effective framework for programming smart contracts, where the state of contract is advanced further based on some predefined criteria and conditions. So, whenever the smart contract is executed, the state of the data will change, and it has now current state. The previous state has changed to the new state. So, smart contracts are inherently required to be deterministic. This property will allow a smart contract to be run by any node on a network and achieve the same result. Deterministic means if that smart contract program is executed on different machines until it will produce the same result, that means it should be deterministic, and this property will guarantee that agreements are fulfilled, and on every machine and on every node, whenever the agreements are verified, that agreements are verified and enforced in same fashion on every machine. That is the guarantee that this smart contract program should provide. So, what are the basic four properties of the smart contract? In definition also we have seen this smart contract program is automatically executable. Once we try to do the transaction, this smart contract program will come into the picture, and it will verify the agreements. If there are some agreements, some conditions that needs to be fulfilled before completing the transaction. So, this smart contract program will verify the transaction. It will automatically execute, it will come into the picture, and it will enforce the agreement. So, this program is enforceable. It will enforce the agreement, and it should be semantically sound, it should be deterministic, it should produce the same result on every node, on every computer, and this program is secure and unstoppable. This program should be secured. If someone hacker tries to get over the smart contract program, and that hacker can execute any kind of agreements, and it can finalize the transaction. So, this program should be cryptographically secured, and this program should be unstoppable. These are the four properties of the smart contract program. So, this is about the smart contracts. So, in previous sessions also we have studied what is blockchain. So, in this session we are focusing on the smart contracts. So, in previous slides we have seen what is smart contracts, then we have to see what is blockchain. Blockchain can be defined as a sequence of hash chain blocks that contains the information. So, these blocks are linked through the hash values. You can see the structure of this blockchain. In previous sessions also we have seen this blockchain structure. The blocks will contain the transaction, and if the transaction is verified, validated by all the nodes, that transaction is appended at the end of the block. Whenever that there is a transaction, the block is created, block will contain the transaction, and block is added in the blockchain when the transaction is committed, when the transaction is finalized. So in this session we have to go into the more technical details of blockchain. So we have to study what are the generic elements of blockchain. So you can see these blockchains are linked through the hash values. First block is called Genesis block. Blockchain contains this Genesis block. Then there is a next block, and this next block is linked to the previous block. And this block will contain the hash of the previous value, and it will also contain the transaction and other data. So you can see these blocks are linked to each other through the hash values. The current block will contain the hash of the previous block, and it will contain also the other data. So we will see in next slide what is this other data the blockchain will contain. So generic elements of blockchain, the blockchain will contain addresses of sender and receiver, it contains transaction, it contains blockchain is a peer-to-peer network. Then there must be some language, scripting language or programming language. As a computer engineer, if we want to design the blockchain system, then which language should be used to design the blockchain system? Then this blockchain elements also contain virtual machine, state machine, node, and smart contract. So these are the generic elements of this blockchain. So you can say address. So every blockchain has this generic elements. It depends on the design of the blockchain. Some blockchain have these elements, some blockchains have more elements other than these elements also. But whatever the basic elements are given in the this list: address, transaction, block. It has peer-to-peer network. For developing the blockchain we require some programming language, scripting language, virtual machine, state machine, node, and smart contract. So we will see in detail one by one what are these generic elements of blockchain technology. Generic elements means what if we want to design the blockchain, then what elements that blockchain should contain. That elements is nothing but the list of these elements, generic elements, that is given in this slide. So in next slide we will discuss more about these elements. So in this slide, students, we will discuss the elements one by one. So you can see the first element of this. So first generic element in the blockchain is address. Addresses are unique identifiers used in a blockchain transaction to denote senders and recipients. To denote the senders, to identify the sender and receiver, each sender and receiver as the addresses, and to identify the nodes, we use the address. And address is usually a public key or derived from the public key. This address is derived from the public key, and while these addresses can be reused by the same user. Addresses themselves are these addresses are unique addresses. However, single user may not use the same address again and generate a new one for each transaction. For each transaction, each user has to generate the new address. So in this blockchain technology, users are not directly identified, but the addresses are used, and by these addresses are encrypted in such a way that we cannot identify the original identity of the node or people who initiated the transaction in blockchain technology. Then second element of blockchain technology is transaction. Transaction is the fundamental unit of a blockchain. A transaction represents a transfer of value from one address to another address. So that there are several types of transaction. and each block in the blockchain contains transaction, and whenever any node wants to initiate the transaction, the transaction is broadcasted to all the nodes will validate the transaction, and block is created. The block will contain the transaction, and that block is appended in the blockchain. Once the block is appended, once the block is added, that block cannot be altered in the blockchain that we have seen. The next element in the generic element in the blockchain technology is block. We know that block contains a list of transaction. It contains the hash value. It also contains the hash of the previous block. A block is composed of multiple transaction and other elements, such as the previous. It will contain the hash of the previous block, timestamp means time information when the transaction is created, when the transaction is committed, and nonce. This nonce is nothing but the hash. This hash nonce is determined from the transaction. Next generic element of the blockchain technology is peer-to-peer network. So this networks, the nodes node is nothing but a computer on a blockchain network, and these nodes are connected through the peer-to-peer network. So we know that what is this peer-to-peer network. We have spent one complete session on type of networks. So as the name implies, a peer-to-peer network is a network topology wherein all peers can communicate with each other and send and receive messages. In peer-to-peer network, every node has the capacity to become the server and to become the client also, that we have studied in the lecture session that is dedicated for type of networks. Then scripting language or programming language. So scripting language or programs perform various operations on a transaction in order to facilitate various functions. So as a computer engineer, we should know this language. If we want to design a blockchain system, then there must be some standard programming language. By using that language, we can start the transaction, and we can do the various operations in the blockchain network. So then next element of the blockchain network is virtual machine. This is an extension of the transaction script introduced earlier. A virtual machine allows Turing complete code to be run on a blockchain, whereas a transaction script is limited in its operation. This virtual machine is not available on all blockchains. Then next generic element of the blockchain is state machine. We have to understand the basic concept of state. This word we have to use again and again, state machine, because the state machine is one of the component of this blockchain network. State machine, whenever there is a data, every data has some state, and when we do some operation on that data, the state of the data will change. Okay. So blockchain maintains the state of the data, state of the blockchain, previous states also and current state also. It maintains the history information and current information also. A blockchain can be used as a state transition mechanism. State transition mechanism means when we apply some operation on the data on block, it will change the state of the that block. A blockchain can be used as a state transition mechanism whereby a state is modified. You try to understand this important sentence. A state is modified from its initial form to the next one, and eventually to a final form by nodes on the blockchain network as a result of the transaction execution. So whenever we execute the transaction, that transaction will change the state of the machine, and this state will change after the validation and finalization of the transaction. So node, we know that what is node. Node is nothing but a computer, individual computer on the peer-to-peer network. What is the role of node? A node can initiate the transaction, and node can act as a miner. It has to verify the transaction. So node in a blockchain network performs various functions depending on the node depending on the role that it takes on. Node can propose and validate the transaction and perform mining. Mining is nothing but the validation of transaction to facilitate consensus and secure the blockchain. This goal is achieved by following the consensus protocol. So whenever the consensus are met, whenever all the parties will agree, that transaction is finalized. So this is the role of the node to create the transaction, to validate the transaction, to verify the transaction, to verify the consensus. And this node may have smart contract program. This smart contract program will see the agreements. It will try to see the conditions. If that conditions are met, then the transaction is finalized. And then smart contract, these programs run on the top of the blockchain and encapsulate the business logics to be executed. This program will execute the business logic. It will enforce the conditions, and if the conditions are met, then transactions are finalized. So these programs run on the top of the blockchain and encapsulate the business logic to be executed when certain conditions are met. If certain conditions are met, then that transaction is finalized. If that conditions are fulfilled, so this program cannot be stopped, unstoppable. This program is always executed. This program is always there, and it will see whether the conditions are met or not. If that conditions are met, then it will allow the transaction. These programs are enforceable, and these programs are automatically executed. Whenever we try to do some transaction, this program will come into the picture, and this program will verify the conditions. If these conditions are met, then this program will allow the transaction. So this is the duty of this smart contract program. So these are the different generic elements of the blockchain. We have studied address, transaction, peer-to-peer network, block, then virtual machine, state machine, node, and smart contracts. All these components will make a blockchain, but as per the requirements of the blockchain, there may be some additional components, or there may be some components that they may not be these components may not be needed in some blockchains. So it depends on the design of the blockchain and its use. For which applications we are designing the blockchain, depending on that depends on what generic elements the blockchain should contain. That depends on the particular applications for which we are designing the blockchain. So next we have to study what is block. Block in a blockchain. So in previous session, students also we have studied block, but in more detail. Technically, we have to study what are the components of block. So you can see block is merely a selection of transactions bundled together and organized logically. In block, the transactions are bundled and transactions are organized logically, and whenever we want to do some transactions, the block is created, and that block has these elements. Again, it depends on the design of the system what elements it should contain, but generally the block should have these elements. The structure of block is also dependent on the type and design of the blockchain. So already I have said you the structure and elements of the blockchain depend on the design of the blockchain. So elements of the blockchains are it will contain the pointer to the previous block hash. Each block contains the hash of the previous block if it is not Genesis block, because Genesis block don't have the previous block. It is the first block of the blockchain. Then nonce is the hash value. This hash value is calculated from the transactions. Timestamp will use the time information whenever the transaction is created, when the transaction is finalized. So this is to keep the record of transaction. This timestamp is important. Then Merkle root also contains hash of all transactions. So we will see in detail what is Merkle root. Then blockchain contains list of transaction. So you can see the elements of blockchain. Blockchain contains pointer to the previous block, It contains a nonce. Nonce is nothing but the hash value which is calculated from the transaction. Timestamp information uh, uh, to keep the record of when the transaction is created, when the transaction is finalized, and it contains Merkle root. We will see in detail what is this Merkle root. And blockchain also contains the list of transaction. List of the transactions are bundled in this blockchain, and if the transaction is finalized, then this block is inserted into the blockchain. It is appended at the end of the blockchain. So these are the components of blockchain. Then we will see what are the elements of blockchain. The first element of blockchain is transaction. Transaction is a record of an event. For example, if we want to transfer some money, some bitcoins from one node to the another node, then we create a some node will initiate the transaction for transferring the bitcoins or some cryptocurrency. Then it contains the pointer to the previous block's hash. A reference to a previous block is also included in the block, unless it is a genesis block. If it is not genesis block, then the block will contain the link to the previous block. Genesis block is the first block in the blockchain, that is hard coded at the time of blockchain when it was first started. Then nonce is a number that is generated and used only once. This number is generated through the cryptographically method. It is for security purpose, and nonce is used extensively in many cryptographic operations to provide replay protection, authentication, and for encryption also. Then Merkle root. Merkle root in a blockchain is present in the block header section of a block. So this students, we have to understand about this Merkle root. You try to focus on this Merkle root. This Merkle root is nothing but the hash of all transactions. So I am underlining this word, this Merkle, which is the hash of all transactions in a block. This Merkle root is calculated from hash of all the transactions. If we want to verify if the block is changed or not, if it is altered or not, we have to check every block. So instead of doing, if we check the Merkle root, then we will come to know whether the block is tampered or not, because this Merkle root contains hash of all transactions in a block. Merkle trees are automatically used to allow efficient verification and verification of transaction. So these Merkle trees are used for efficient verification of transaction. If we know the Merkle root, then there is no need to verify every block in the blockchain. This means that verifying only the Merkle root is required to verify all transactions. If we want to verify all transactions, then it is only essential to verify this Merkle root. Otherwise, we have to verify every transaction, whether that transaction is altered or not, whether that block is altered or not. But this Merkle tree provides a very good facility. By verifying only Merkle root, we will come to know whether the transaction is altered or not, or whether the transaction is changed out or not. Instead of verifying all the transactions one by one, we have to verify only Merkle root. So in coming sessions, we have to study in detail about this Merkle root. So these are the elements of block. A block contains transactions, pointer to previous block, nonce, and Merkle root. So transactions in blockchain. So dear students, this session become a long session. So we will discuss about these transactions in the next session. So today I will wind up this session. So we have studied in previous session what is public ledger, Bitcoin, and in current session we have tried to study what is smart contracts, blockchain. Blockchain is a it is a chain of blocks linked through the hash values. Then what are the generic elements of blockchain? Every blockchain don't have this all these generic elements. Some may have additional elements also. Some elements may not be needed in blockchain, so that depends on the design of the blockchain. But every blockchain has transaction, peer-to-peer network, address, nonce, smart contracts. If we want to enforce some contracts, some conditions, then we need the smart contracts. If we don't want to enforce any condition, then there is no need of smart contract program. Smart contract program is a program. Then we have studied what is a block in a blockchain, and block elements also we have studied what each block contains. and blockchain transactions we will discuss in the next session. So thanks for watching.